Chapter 6, Section 4, Applications of Linear Systems. Let's review really quickly. Remember, we have 3 different ways to solve systems. The first way that we learned was graphing. To solve a system by graphing, you go ahead and you graph both lines in the same coordinate plane, and you find the point of intersection. One negative thing about graphing was if you had a really big numbers for your intersection, like if your point was 57, 34, then that means you had to extend your y-axis all the way to 57, you had to extend your x-axis all the way to 34 to even see the point of intersection. So that was one of the bad or negative things that we learned about graphing. There were 2 exceptions to finding the point of intersection. Sometimes you might have 2 lines that are parallel, meaning that they have the same slope but different y-intercepts. If you have 2 lines that are parallel, they're never going to intersect, which means that there never is going to be a point of intersection, so we would have no solution. The other exception was when we had an infinite number of solutions, which is the case when you have one line that maps directly on top of the other line. So if you are graphing the same line twice in the same coordinate plane, that would mean you have infinite number of solutions. Every point on one of the lines is also going to be on the other. The next way that we learned was through substitution. To use substitution, we needed to isolate one of the variables, so get either x or y by itself on one side, and then you could substitute that in to the other equation for that value. So if you had like y equals x plus 3, then you could plug in x plus 3 for y into the second equation or the other equation and solve for y. And then the last one that we talked about was elimination. To solve through elimination, we would add or subtract the entire equations, all of the like terms in each of the equations, and we would, to eliminate a variable, and we could have had to multiply one or both of the equations by a number to use the elimination method. For both substitution and elimination, you're going to solve for one of the variables using that method. Then what you're going to do is you're going to take that number. So if you got like x equals 3, then you would take 3 and you would plug it into one of your original equations that you started with to solve for y. So you'd plug in 3 for x, solve for y, and then that would give you your ordered pair. You could plug in that value into both equations and it should give you a true statement for both if it is the correct answer. The thing about substitution and elimination that is the same would be there is no solution when you end up with a false statement. So if you get to a point when you're using substitution or elimination and you get something like 3 equals 7, that's a false statement. 3 does not equal 7, so there would be no solution to that system of equations, or the lines would be parallel. The other thing that they have in common is that when they have an infinite number of solutions, you're going to end up with an identity, which means you're going to get 0 equals 0, or 3 equals 3, 7 equals 7, something like that, and that means that any ordered pair that's on one of those lines is going to be on the other line as well. So it would have an infinite number of solutions, or it would be the same line. Systems are used in real life for mixtures, rates, and break-even points. This first example says the sum of 2 numbers is 105. The larger number is 7 more than the smaller number. What are the 2 numbers? I chose to use my variables s and l for smaller and larger. It really does not matter what your 2 variables are. You could have used a and b, you could have used x and y. Anything is totally fine for this problem. So the first statement, or the first sentence says the sum of 2 numbers is 105, which means I can take the smaller number plus the larger number and they would equal 105. So I said s plus l equals 105. Then it says the larger number is 7 more than the smaller number. And then what are the 2 numbers? To write an equation, the larger number is 7 more than the smaller number. I wrote the equation s plus 7 equals l, or the smaller number plus 7 equals the larger number. There's another way that you could have written this. You could have said the larger number minus 7 equals the smaller number. Either way is totally fine. You should wind up with the same answer if you use either one of those equations. If you look at these two equations that I've written, I have s plus L equals 105, and then I have s plus 7 equals L. If you notice in my second equation, L is already isolated. It's already alone on one side. So I'm going to choose to use the substitution method, and I'm going to choose to plug in s plus 7 for L into the first equation. So that would be s plus, instead of L, I'm going to put s plus 7 equals 105. Well, s plus s is 2s plus 7 equals 105. I need to subtract 7 from both sides. When I do that, I get that should be an s. 2s equals 98. Divide both sides by 2, and you get s equals, that should be s again, I apologize. So this should be s equals 49. Now I'm going to be able to plug that in for s into the second equation because it's going to be super easy. I can say 49 plus 7 equals L, and then you get 49 plus 7 is 56. So your two numbers would be 56 and 49. I apologize, I made a typo on those two, that 2L equals 98 and L equals 49. Both of those should be S's. This is a combination problem. This problem, what I will tell, if you are in my personal class, what I will tell you is that I am giving you this example. You will have a problem like this today in your homework. However, I will not put a type of question like this on your test. I just want you to be exposed to it so that you can see it. However, like I said, not going to be on your test, so don't worry about this. But you do need to try to follow along, and you will have an example to do on your homework. It says a scientist has a container of 2% acid solution and a container of 5% acid solution. How many fluid ounces of each concentration should be combined to make 25 fluid ounces of 3.2% acid solution? We have two different things going on. First of all, I can't just plug in percents. Like for 2%, I can't just plug in 2. I have to change it to a decimal. Remember, to change a percent to a decimal, you move the decimal to the left 2 places. So instead of 2%, I would have 0.2, and instead of 5%, I would have 0.5. The first thing that I'm going to do is say X is the 2% acid, Y is the 5% acid. I know that I need 25 fluid ounces, so however much I mix of the 2% solution and the 5% solution, I know that it needs to add up to equal 25 ounces. So there's my first equation. Then I'm going to have 0.02x. That's where I've changed my percent to a decimal. That's the percent of acid that the X solution is, plus 0.05y. 0.05 is 5%. That's the percent of solution for the Y solution. And then I have to multiply 25 times 0.032 because I want to know, out of the 25 ounces that they want, how many ounces are actually going to be just acid. So I take the 25 ounces that I'm going to have, and I multiply that by the percent of acid that I want in the solution. The percent of acid was 3.2%, change that to a decimal, and you get decimal 0.032. I need to go ahead and multiply 25 times 0.032, which gives me 0.02x plus 0.05y equals 0.8. What I'm going to do to solve this system of equations is I'm going to go ahead and go back to my first equation, x plus y equals 25, and I'm going to solve for one of those variables so that I can use substitution. I chose to solve for x by subtracting y from both sides. You could have totally solved for y by subtracting x from both sides. Either way would be completely valid. This is just the way that I did it. When I get x equals 25 minus y, now I need to take that and I need to plug in 25 minus y in for x into my second equation. When I distribute my 0.02 times 25, I get 0.5. My 0.02 times negative y, I get minus 0.02y. Plus 0.05y equals 0.8. Go ahead and combine your y's. You have a negative 0.02y plus a positive 0.05y, which would give you 0.03y. I need to subtract 0.5 from both sides, which gives you 0.03y equals 0.3. Divide both sides by 0.03 and you get 10 ounces of the y solution. I'm now going to take that 10 and I'm going to plug it in for y into the first equation. So it would be x plus 10 equals 25. Subtract 10 from both sides and you would get 15. So there's going to be 10 ounces of the 5% solution. And there's going to be 15 ounces of the 2% solution.